NASA's sound of the sun and frequency of Om, it matched accurately.
Visually, the frequencies matched. We don't know what the frequency numbers were. This is a very, very nice, typical so-called Fourier spectrum.
These findings were documented ages ago in ancient Vedic texts.
We should always study, if possible. That never hurts. I am aware of this Vedic stuff because besides astrophysics, I also have a degree in history, and my specialization was Indology, actually.
What does the sun sound like? In this interview, I'm being joined by the man who helmed this entire research on the sound of the sun at Sheffield University. He's someone who helped the modern world, today's world, hear what our sun sounds like. It is my absolute honor to introduce Professor Robertus Erdelyi. He is the head of Solar Physics and Space Plasma Research Center in School of Mathematics and Statistics, University of Sheffield in the UK. He's been awarded an innumerable number of times for his outstanding contributions to solar theories over the decades. Professor Robertus, thank you so much for joining me here.
Thank you very much for the opportunity. It's a pleasure for me to talk to you guys. I have quite strong connections with India, so I am very happy that this has made India as well. And thank you for your nice words.
Yeah, and I'll definitely like to delve into those connections very shortly. First of all, sir, we've heard the audio on the sound of the sun from Sheffield that you conducted the experiment, the sound that was captured from the sun. What aspect of the sun did you capture on sound, if you can explain to us?
Okay, let me explain this a little bit in a broader context. What we have done, we haven't detected the sun at the solar surface. That has been already done probably 40 years ago. What we have detected is more the noise, sound, I call it music sometimes, in the solar atmosphere. It's a bit like this, that like on Earth, we have the Earth's surface, the ocean, that can make some sort of noise, but the air itself, the air above the atmosphere, it makes a different noise. Now, what is important in the case of the sun? It's a star. It's made of the fourth state of matter. We are all familiar with solid, liquid, and gas, but there is actually a fourth state of matter. It's called the plasma. In fact, more than 99.9% of the universe is in this fourth state of matter. It's a little bit like gas. It's a little bit like liquid, or like water, for instance. And this is what stars are made of, galaxies are made of, etc., etc. And what we have done in the surface of the sun, above the surface, it's a little bit like, if I make an analogy, we have the Earth, and then you climb up to the top of the Himalaya, for instance, and you would be very surprised if the Himalaya would be hotter than, for instance, down at Delhi level or Bangalore level. What stars do, most of the stars do, that their surface is actually cooler than their atmosphere. This is a very, very big question in science, and a lot of effort goes into it to understand why the surface of the sun is hotter. And what we have done in this hot environment, there are magnetic fields. And these magnetic fields, they resonate, they move, they oscillate, if you like, and that oscillation can be then detected in some very smart ways with satellites or even from the ground, from Earth. For instance, in India, you have wonderful observatories. In Kodaikanal, there is one. I think that's the leading one as far as this area of science is concerned. Another one in Nainital, but there are more places. But these are the well-known ones. And we have all sorts of instrumentations, also satellites. India also has recently launched a satellite called Aditya, and they also study this part of the sun.
Understood.
We haven't used we have used some other tools, some European satellites and American satellites, jointly built by Europe and the United States and some other nations. And we used observations, and then we detected these oscillations, these resonations in the atmosphere. And then we changed the frequency, accelerated the frequency into the human ear frequency range, and then you can hear this.
So it's the outer layers, as you mentioned, the air above or the Himalayas, like basically it's not at the surface, it's above it. I get it. I understand your point, sir. Let me come to the next part of it. In my research, I also understood that NASA also released their recording of the sound of the sun. I have chanced upon a research by an Australian professor and lecturer on sound at TAFE University, Adelaide. He mapped the frequency graph of NASA's sun recording and started comparing it with the frequency chart formed by the sound of Om when it is chanted. Now, in his sample size, he compared Om chanted by a Vedic scholar, Yogi Ashwini ji, who is an authority on Vedic mantras and recognized by leading authorities for his practical demonstrations of yogic siddhis. Now, when the Australian professor superimposed these two charts, the result was astounding. I'd like you to hear the recordings. You'll have the video in front as well and just see the frequency maps between the two.
Okay.
Now,
Okay.
NASA's sound of the sun and frequency of Om, it matched accurately. The two graphs, they overlapped with the same crests and troughs when superimposed upon each other. Professor Robertus, how do you infer this finding by the Australian sound lecturer? Because the maps, they show something very similar, and frequency, anyone understanding frequencies, crests and troughs, they don't start matching like that unless there is some similarity.
Okay, so first of all, I did not hear the sound. There was only this visual frequency match. I could not hear on the video the actual noise or whatever it was. The second one, we have to be a little bit careful because there were no frequencies. Visually, the frequencies matched, but we don't know what the frequency numbers were. So whether this is really the same number in the case of what NASA released and in the case of what this other releases. So we need to see very clearly whether these frequencies are really matching. What you have seen actually is, let's suppose that this is correct. Let's suppose. I don't know, but let's suppose this is correct. What we have seen here is some frequency peaks, as you pointed it out rightly. This is normally when you have a broadband signal, all sorts of frequencies are part of it. What we can do with a mathematical tool, we decompose it into peaks. This is called a Fourier transform, right? It's a technical term. Most of the audience will not know what it is. It doesn't matter. What is important is that if you have a broadband signal, you can split it into frequencies. Now, if we have some noise from the sun and if we have some other noises generated by maybe a guitar or a sitar or whatever, I can make this frequency split, and I can always make, not always, but I can, with a high chance, I can match the frequency peaks visually, but it doesn't mean that the frequencies themselves match.
Professor Robertus, just allow me to come in there. As you mentioned, you weren't able to hear it. I'll request my production control room if you can play the video again, because there is audio and I'd really like you to hear it and see the videos being formed with the audio. Ashma, if you could try that again, please.
I don't hear, I see the peaks, the frequency peaks. This is a very, very nice typical so-called Fourier spectrum. Yes, yeah, again, I don't hear the peaks. I can see it, but I don't hear the actual... I only can see visually the frequency.
Are you able to hear it now?
No. But it's fine. It's fine.
All right. She says, I think we both have the same audio input, so I'm able to hear it. But let's move further from there, I understand. But, just taking a little further from there, sir, I can send it to you. You can try it yourself as well. I can send both the audios. Of course, NASA's audio is very much there. It's there. They've put it up on their official YouTube page, on their website as well. And the sound that I picked up from Yogi Ashwini ji's chant of Om. And the results can be accorded. You can try it with anyone else's Om as well, because it was a very large sample size that this Australian professor tried. There was one specific Om which was matching, and this happened to be a Vedic scholar who excels in this science. Now, I wanted to understand from you, this is exactly what Vedic texts also say, that Om is the vibration of the sun, it's the vibration of the creation. These findings were documented ages ago in ancient Vedic texts. Maitreya Upanishad mentions sun represents Om. Chandogya Upanishad equates Om to the sound of the sun. Mandukya Upanishad mentions Om. Surya Siddhant, it's an ancient Vedic mathematical empirical treatise rooted 12,000 BCE, focused on celestial mechanics. And a large part of the findings in Surya Siddhant, trigonometry, planetary dimensions, they are now even recognized by modern scientific community. So if some part of it is now being understood and found accurate, and as you also mentioned that they look similar, shouldn't other aspects also be studied further, or would you say one part is right and then the others aren't?
What I would say, we should always study if possible. That never hurts. What I would like to point out before we make maybe too far interpretation of this, when you hear these frequencies, are you still here? Because now I lost your picture.
I'm very much here, sir. Can you hear me?
Okay. But now I can see you.
Yes,
Yes.
please.
So what is important is that the noise of the stars, like the sun, is not in the frequency range of what humans can hear, right? So the humans can hear between 20 hertz up to 20 kilohertz, more 1,000 hertz, yes, more or less. So when we make these recordings, we shifted these frequencies, we accelerate these frequencies into the range of human ear. I can always find, not always, but likely, I can find matches, right? So if I take some sort of noise and I decompose into these peaks, I can always find some parts of the matches between two frequency ranges if I shift it a little bit. So it would be nice to see the details of how exactly this Australian colleague has done this frequency match. I'm not saying it's wrong. All I am saying is that when you take a long sample, part of the sample could match another part of another sample. It's not that difficult to make these sort of things. And so I would like to be a little bit cautious here. I am aware of this Vedic stuff because besides astrophysics, I also have a degree in history, and my specialization was Indology, actually. And I did quite some work on the Harappa civilization, your ancestors, in a sense. So I am really into this, and I like these sort of things. And when I did my studies in the Harappa civilization, they have done excellent stuff. And then what comes after it, the Vedic aspects are really fantastic progress. It's a fantastic progress in science and also in philosophy and in religion. But I would still say that we have to be a little bit careful before we make too much interpretation. And of course, please don't forget, if you are a believer, you easier accept these sort of things. If many people are not believers, for them, sometimes the threshold is higher to accept when they see some coincidence.
The frequencies that Sheffield was able to map, the sound of the sun, it was mapped with Yogi Ashwini ji's chant with Om. Now, the sounds were identical, but the frequency charts were in fact different. Whereas with NASA, it's superimposed accurately, as you could also see, and it's very evident. When you introduced to us the sound of the sun that Sheffield matched, that was from a distance from the surface. When NASA took their understanding of the sound of the sun, it was the interior sounds. When I mapped the frequencies, NASA's frequency matched accurately with the Om chant that we heard, but when I matched the same with the Sheffield sound of the sun, it was not matching. So I wanted to understand from you, while you've taken a part of it, the sound is like Om, but the frequency chart doesn't match. Can you explain that part?
Yes. So that's the whole. Yeah, I understand what you are asking. Actually, you summarized it quite nicely, and I hope that it was understood in layman terms. So the NASA measurement is indeed the interior oscillation. The sun is a three-dimensional ball, if you like. It's a plasma ball, and it contracts, expands, contracts, expands, contracts, expands. And the frequency peak of this oscillation is at about 5 minutes. So there is a 5-minute oscillation. This 5-minute oscillation you are not able to hear with the human ear because the frequency is millihertz and we cannot hear millihertz. The lowest frequency is about 20 hertz, right? And we are talking about thousands of that number. So what they have, what you can then do, you accelerate this frequency range into the human ear, as I mentioned before. So what they measure is the interior oscillation of the sun. And the interior oscillation is not really strongly influenced by the magnetic field of the sun. Every star, most of the stars have quite important magnetic fields. Some have less important, some more important magnetic fields. The interior the physics of the interior is not the physics of the way the sound is generated and the vibrations are generated inside a star like the sun is not so much influenced by the magnetic field. However, the atmosphere is completely different. In the atmosphere, if you go away from the surface of the sun a few thousand kilometers, then the magnetic field is very important. And the magnetic field is the decisive factor what will determine all these vibrations, etc., etc. So that could be the reason why these frequencies are not exactly the same. Very roughly speaking, as I said, 5 minutes and 3 minutes oscillations are very typical at the surface, while in the atmosphere, the oscillations can be much longer, sometimes 10 minutes, 20 minutes, even longer oscillations do exist. But sometimes it depends on the actual local magnetic structure. The magnetic field is organized into loops, as you said, in the atmosphere. It's a bit like donuts. It's half donuts. This is how normally we visualize these magnetic fields in the atmosphere of a star like the sun, and then they resonate, they oscillate. They do the same thing like a sitar. You know, when you play a sitar, you pluck it, and then you have some response. These magnetic fields are something like that. But their properties and the way they resonate are in many aspects different from the internal oscillations.
So when the internal oscillations match the frequency vibration chart, the graph with the Om chant that we heard earlier, but the peripheral ones, or I'm saying it for very layman's terms, the way I would understand it, sir, so please pardon my basic understanding of this, but from a distance when you take it, you mentioned the oscillations and even the magnetic fields, which are away from the surface, that would be a part of the sound of the sun, whereas the internal sound would be matching perfectly with Om. So how, when you take it in context to the chant that we heard, how do you deduce from this?
Yeah, as I said, since I haven't seen the way the frequency matches were done, you know, in science we believe in things what can be repeated. If this colleague has published this somewhere, then it's probably achievable, accessible, so not achievable, accessible, then we can easily repeat and we can check whether the methodology used was correct. I'm not saying it's not correct. What I'm saying is that when we publish something, we always try to independently verify it. The coincidence is quite interesting. Visually, these two frequencies you showed, the ohms and the interior, when you visualize, I still say I couldn't hear it, but the visualization was nice. As I say, my little concern is that none of these frequencies are auditable, right? You don't hear it, so you shift it. Then how you shift it, as I said, you can always shift frequencies in a way that they make.
Pardon me, sir, but the sounds are audible. So when you say frequencies aren't audible, the sound was audible. I can send you the file. I'll send it across to you on WhatsApp, and you can study the sound as well.
No, it's not audible because the frequency range, as I said, the periods. Let's talk about periods. It's easier to understand. The period is around 3 minutes and 5 minutes. That you cannot hear. In order to make it audible, like we did it with ours, we have to accelerate it. We bring it into the frequency range audible for humans. So this is what you hear is not a real oscillation. Well, it's a real oscillation, but it's not the direct oscillation what you observe. It's changed. It's a little bit like this. Like with light, you have the light frequency in some range, say X-ray. We all know X-ray or infrared, and I can shift this into the light range, into the frequency range, what we can see. Say between 4,500 up to, I would say, 8,000 angstrom. Right? This is also a trick where what we very often do when we want to visualize things, because you cannot see X-ray, you cannot see infrared. These light ranges, it's not visible for the humans. But we can still make them visual by shifting this phenomena into the frequency range or period range or wavelength range, what is sensible by the humans. And that's what they have done. Absolutely. And in both, so this is very important to point out. And we don't know how exactly they have done this, because the methodology, of course, you can't show it here, and it's not even your job, to be honest.
Oh,
it would be nice
I understand. I understand your point, but I mean, I think what I'll also try to do is get more, aspects of the study. I'll have it passed over to you, and you can also study the frequency range, because this is, I would not like to comment on something which I do not understand completely. Research is something I can definitely do. Those findings is what I'd put across to you. The frequency range of both the sounds, which are very easily audible, and they map accurately, as anyone can see, and they can try for themselves as well, and then see the difference. But just taking it a little further from there, sir, I also wanted to discuss the study of sound further with you, because study of sound, the sound of the sun, is what you've gathered. The science of sound and vibrations. The US recently used sonic boom technology. It's a secret sonic weapon they used to capture Venezuelan leader Nicolas Maduro. Sematics talks about the visual representations of sounds. Japanese scientist Masaru Emoto, he conducted well-known experiments explaining the effects of sound and the formations of the sound that move parallelly to it. In Vedic texts from thousands of years ago, it explains how every mantra, which is a codified form of energy, there is a corresponding yantra that is formed, a formation for it. Even in the sound of the sun, the frequency matches with the correct chant of Om, like we heard and like we just saw with the Australian professor who deduced this. My point is, this is something that the world is using, but it's already documented in Vedic texts thousands of years ago, some of the texts I mentioned. You've been able to tap into the sound of the sun, sir. Can't we have more study on impact of sound from someone of your learnings and stature, and get Vedic perspectives on it from someone adept and validate it for the Vedic sciences?
Okay, yes. This is very interesting what you say. You see, it's always down to these religious texts are down to interpretation. Some people believe in it. For them, this is absolute, and there is no question of interpretation. There is only one way. But not everyone has the same religion.
So that's my question. Pardon me, I'm butting in, and that's my question, because when we have scientific background, then it gives weight, because things that science is now understanding, these were already documented, and some of them are dating back 12,000 BCE. So, how do you put the two things together? Because this is not mumbo jumbo, as mostly some people would want to call it. But
it's very interesting.
But
I can give you another example.
Yes.
Yeah, it's very interesting. I can give you another example, maybe even more, how shall I say, bigger impact. That in the Christian religion, we believe that, not personally me, but in the Christian religion, it is believed that Adam and Eve, they were the first humans on earth, and we are all descendants of them. So we have only one mother, right? This is very well known in the Western world, and I guess in your part of the world, in Asia, is also known. And there are texts on this, and the Bible, etc., etc. And then modern research about maybe 20 years ago, I would say about 20 years ago, when this is really started, scientists actually in the UK started to look into the identification of the lineage. Yes, what is your origin? And there was a UK scientist who discovered that more than 95 or 99% of Europeans are descendants of 7 women, right? It's quite interesting. And this discovery is correct. And then this discovery went a little bit further in the last couple of decades. And now, as I understand, they have identified a so-called single gene, which is the origin. All of us on Earth so far, there was not a single counterexample found who does not have that origin, that does not have that element in his or her gene. So what I try to say is that, in a sense, they have identified the first person who are we all descendants of. Now, if you think about it, that the Bible was written about a good 2,000, maybe more, 2,000 some years ago, how on earth those people knew about this? At that time it was only thinking, if you like. It's a bit similar what you said, the Veda text, that 12,000 years ago they have written down something, and today we prove scientifically some part of this is correct. I think it's very interesting. Whether this is coincidence or not, I think this is another question. But sometimes we shouldn't throw away all the biblical texts or religious texts. Another example is, for instance, the Great Flood. As far as I know,
and that's mentioned everywhere. in
As
all.
mentioned earlier.
Yes.
And you know, there are scientists, and I am one of them, who believes this has happened about 11,400 years ago. Not everyone accepts this. Not all historians agree to this, and there are some consequences of this. Again, it's a very interesting thing. So we should not throw away statements in old, whether it's religious or whatever text it is. We should be critical and try to prove, if possible, or disprove some statements. So I am not against at all what you suggested to find some truth in all these texts. It is possible, but we have to be a little bit careful, because coincidence can also be a factor here, and we should accept the statement only if we can prove it independently.
100%, sir. Well, when it comes to trigonometry, planetary dimensions, all mentioned in Surya Siddhant all those ages ago, and distance from between the Earth and the Sun mentioned in the Hanuman Chalisa, that's also very much there, documented ages ago. There are a lot of understandings when it comes to the layers of the skin, which was given by Shushrut. That's also there in the Shushrut Samhita. These are ancient texts I'm talking about, and also the atom, the Kana jisko hum kehte hain, we call it, Rishi Kanad had given it, what the atom means, and the molecules, and all of that came. I'm not putting any religious connotation to this. I'm just saying these are ancient Vedic texts, these are ancient texts. Let's take it there, and it deserves more understanding. I think with somebody like you at the helm of it, there will be more revelations today, what perhaps were already there at an earlier time. Would love to discuss this more with you, Professor Robertus Erdelyi. Thank you so much for joining me here, and I'd like to keep in touch with you so that we can discuss other aspects of this, which can be taken further and understood more, so that the world gets up and wakes up to things that have existed in the past. Thank you so much.
Thank you very much for this opportunity. And also, I would like to congratulate to you guys in India that you have this new satellite, Aditya, and hopefully more will come in the future, because this is fantastic development. If you think about it, where your country was 30 years ago in space technology and where you are now, you have done a massive leap forward, and congratulations. That's all.
Thank you so much. Always an honor hearing these words from you.
Thank you very much.
Thank you, Professor.